Okay. So, given the font map that we have, what we want to do is go ahead and render part of it, right? If we go ahead and pull it up here, if we want to look at only the A character, we want to just not render any of this, and not render any of this, only render this, and then not render anything after, right? So it's essentially like rendering part of a sprite. And that is going to be uh, very similar to how we are actually going to be dealing with it, right? What we will do is let's make a function, and this is going to be render glyph, and it's going to have our classics, right, of bitmap, pitch, and then we are also going to go ahead and pass in the um, the font sprite. And then we are going to go ahead and pass in the char glyph, right? And there's something else that we need to go ahead and draw this. What we really desperately need is we need a way to know how big a character is in the bitmap. Oops. Here we go. You'll notice that the way it's packed together, it's very tight, right? So the exclamation mark, which is super thin, is right next to the quote mark. And the A, which is a little bit, wider than the exclamation mark, is taking up more room. So we want to go ahead and know how much room that character is actually taking up. And luckily for us, STB keeps track of that data for us in this baked char. Now, what I personally would like to do is go ahead and convert this baked char into our own struct. And I'm going to go ahead and call this, we'll just go ahead and call it glyph. And the reason that I want to do that is that right now we are depending on STB true type, right? And we're depending on it at runtime, right? It has to be included in the project. We have to start our program, create the file, do all this stuff. And if we start requiring STB baked char, like if I have right here a baked char in our function, then I'm never really going to be able to get rid of it, right? Or if I do, I'm going to have to do essentially what I'm going to do now, right? So this is a very common thing in game engines and just other, complicated pieces of software, is you often want to be converting things into your own data format so that you don't necessarily depend on other people's representations of data to do your work. You can go ahead and use their representations of data when you need to, like in this case we do if we want to use this baked font bitmap, which is very useful to us. But I don't want to go ahead and rely on that forever. There might be things that I want to store in addition to this baked char stuff, right? I might want to know other details about the letter, right? So what we are going to do is make a glyph trying to think. Actually, right now, maybe all we care about is just the glyph, right? So what we are going to do is say that we have hey, a uint 16, and this is going to be x0, y0. I'm going to go ahead and write them out like this. x1. And then we're also going to have our x offset and a float for y offset. Remember that float is a real number. And then we're going to have a float, which is x advance. And that should do it for right now. So what I want to do is go ahead, and after we've baked the font, I want to say for everything in our char count, I want to go ahead and say that, hey, I am going to make a glyph pointer. It's going to be, again, struct glyphs like that. We'll do malloc size of struct glyph times the char count, right? And now I'm going to say glyphs of I dot x0 equals, I call it here, oh yeah, baked chars, duh. Baked chars of I dot x0, and then we're going to do the same thing for x1. And you know, this is not super interesting. It's just essentially copy and pasting data from one place to another. But it is, I think, a good practice. And this is going to be x offset and y offset, right? The other thing I would like to do is, well, let's see what the, yeah, I think this is okay for right now. So we want a way to go ahead and map from a certain glyph to, or like from a character, right? We want to say, hey, render A, and then it goes ahead and looks up the glyph for us, right? We don't have to worry about that right now. Right now, we can just say, hey, render glyph 1, render glyph 2, etc. And we should be good to go. That's just something we will want in the future for our own peace of mind, right? So, again, this is going to be pretty much like our render rect and render sprite. The only difference is that we are going to be not rendering everything in it, right? So we're going to want to look at some of the stuff in the glyph to find where in our font sprite we should start drawing things, right? So we're going to say here, we're going to say sprite row is going to be our font sprite dot data. And again, I'm going to want to go ahead and compute our sprite pitch. It's going to be font sprite dot width times 4. And the first thing we want to do is find, okay, which row of this sprite do we want to start looking at, right? And we will do that by saying it is going to be the glyph, it's going to be the glyph dot y0, which is the top left, or it's the top part of the glyph, right? So we're going from y0 to y1, top to bottom, right? Times sprite pitch, right? And that is giving us the row that we are on, right? So if we have this, then if our start y is at here, that's going to be, if it's 0, that's going to be the row we're starting on. If it's 1, it's right here. Now, if we look at our font, we can see that, let's see. Well, actually, I guess everything is pretty much starting at an even footing, right? So they're all starting at the correct row, or not even the correct row, but they're all starting at the same row, right? But they don't always go on for that whole row, right? Like we can see right here for the comma, it is not as tall as the A, right? Okay, so that is giving us a pointer to the row that we're on, right? Now, what we want to do is for our width, right? So this is going to be like glyph width, right? I'm going to do that. So we need to go ahead and compute the glyph width. So let's say glyph width, that's going to be, or sorry, I meant height. It's going to be glyph height is going to be glyph.y1 minus glyph.y0. And then we can do the same thing for width, right? All right. So we know the row that we are starting on in the sprite. What we don't know yet is the the column that we're starting at, the pixel that we're starting at. So let's go ahead and say right here, we'll call this sprite pixel, right? And that is just going to be the sprite row plus the glyph.x0, right? So again, we're going to look at the row. We're going to move over some number of pixels. Remember that our well, it's actually kind of interesting. Our font sprite is 4 bytes, but we kind of don't want it to be. We want it to be the same thing pretty much that we were passed in. I think it'll be okay to do it this way for right now. We might want to go ahead and change it back, because really the thing is, like, we don't really care what the colors of the font are. It could be, baked in with like hot pink and vomit green, right? And we don't really care because we're going to pass in the color that we want to draw the characters. So since we're dealing with a sprite right here, let's go ahead and make sure that we do this times equals 4, right? To calculate the pixel that we are at. And now what we want to go ahead and do in here is say that our see, where is it? Yeah, we want a UN8 pixel, which is just going to be the row, and we want to go ahead and do the row plus equals pitch, right? Just like that. We want to say that, all right, hey, pixel is going to equal something in the glyph, and then pixel plus plus, right? And we're going to do that several times. So we want to say yeah, we just want, say, sprite pix. And again, we don't have to do this whole 22103 thing because we have our font sprite now. We know what the colors are, and we know the order that we're in. So we can just go ahead and say, all right, sprite pix, and then we'll do sprite pix plus plus, right? And let's go ahead and do that a couple of times, or 4 times to be exact. Let's see, we want this to actually be plus start x. What is it? Start x times 4, right? Because again, we want to be at the correct place in our screen pixels, right? And we want to only move glyph width units over, which is all looking reasonable. I can't help but feel like there's something probably wrong with this that I'm missing, but we'll see. Oh yeah, it's well, this isn't what I fear is wrong, but it's not struct glyphs, it's just struct glyphs, right? All right, so nothing terrible happens. We don't crash. Let's go ahead and actually say, all right, we want to draw a glyph, which means we're going to pass in the bitmap, pass in the pitch. Let's go ahead and stop drawing the font so we can just draw something at 0, 0. Let's also stop drawing the player. We'll just have fewer distractions. Let's see. Oh, it's I called it render glyph. I just want draw glyph. So it's going to be 0, 0. We want to pass in the font sprite, and then let's find the glyph that we want. So this glyph is going to be, let's look up in glyphs. We're going to take, well, let's just do 0, right? So in fact, we could just say like that, right? Again, it's my plural confusion. All right. So we aren't seeing anything. Let's go ahead and see why that might be. Well, for one thing, we aren't ever moving further in our sprite, because we also want to say, hey, sprite row plus equals sprite pitch, right? Let's go ahead and see if that fixes anything. It doesn't seem to, but we know that that was incorrect, right? All right. Let's go ahead and look at our draw rect just for reference. So we have a row. So we are calculating the correct row and pixels. So we should be drawing it in the correct place on the screen, right? The issue, I suspect, is that we aren't actually looking it up correctly in the sprite. Well, for one thing, we should be doing this here, right? Where we are, every time through, we're going to start getting the pixel starting at the new row that we've computed once we've moved on to the next row, right? So that is a mistake. Okay, yeah, we are moving the rows correctly. And the glyph height and the glyph width. Oh, I know what it is. The first glyph is a space, isn't it? Um, that would certainly be invisible. One, though, is an exclamation mark. Awesome. Let's try, I don't know, 30. We have that one. Okay, cool. Very, very neat. So an easy way to do this is so we know that we're starting at 32. So anytime we want to render like a char like this, right? So if we want to render A, which is 65, we know that we're starting 32 from the center, so we could do like A minus 32, right? So if I did that in here, if I said A minus 32, we should be getting, if I actually compile, we should be getting an A, which we are, which is very cool. So keep in mind that these glyphs are not all going to be the same size, right? So the number of pixels that we're actually drawing right here is different than the number of pixels that we are drawing right. Oops, I did a 1. I want an exclamation mark, right? Than we are right here. So this isn't like a sprite in the sense that a sprite is just always like a size, right? And even if some of the pixels are black, we would still be drawing them, right? If it's 200 by 200 and only the top left pixel is white, we're still going to draw the rest of it. Here, though, we are going into our texture and we are sampling out a little piece of it. Or, sorry, we are going into our sprite, right? Our font sprite. And we're sampling out a little piece of it and only drawing those pixels. So here, we're probably only drawing, like, I don't know. Well, in fact, we can actually go ahead and see exactly how many we are. Let's go ahead and say right here, printf. We'll do that, and we'll say glyph width, glyph height, right? So looks like we're drawing, well, that's because I forgot the new line. I always forget the new line. That's why in my own game engine I just say, hey, print, and it automatically puts the new line. So yeah, we're only drawing, 10 pixels wide by 63, right? So we're sampling this very small little section of our bitmap, or, our font, right? Which is actually kind of exactly what we want, right? Because if we went ahead and made a sprite for every single glyph in the game, we would have a lot of chunky data, right? We would have to be allocating space for every single thing, right? We would have to say, all right, hey, this character is this many pixels wide. Go ahead and make this many pixels. And just doing that over and over again, right? Which, is probably not that bad. Computers, even Raspberry Pis, are very fast. At least, compared to computers that I would have grown up with. But it's still maybe a little faster to just say, hey, we have this giant chunk of memory that represents all of the things that we can draw, all of the letters that we can draw. When you want to draw a letter, just go ahead and look up which letter you want to draw in there, right? And it's also very nice because we have this really elegant mapping between saying, hey, here's a character, go ahead and look up the glyph. So actually, what I want to go ahead and do is make a little function which is going to return a glyph, and we'll call it get glyph. We're going to pass in a character, and we're going to pass in a pointer to all of the glyphs, right? And then we're just going to return the glyphs of C minus 32, right? Maybe we want something a little nicer. Like, what if we decided to start at 40 instead of 32? Well, things would start to break. Right now, we don't need to worry about that. We can just see how this function works. So now we don't have to worry about doing this minus 32. We can just say get glyph exclamation mark glyphs, right? And we should... looks like I made the same mistake again where I said struct glyphs, and that's not what I want. And then, see, go ahead and clear this. Unknown type name glyph, where, yeah. All right, cool. So if I wanted to say, let's go ahead and do this, right? I don't know, let's set these, do 50, 100, 150, right? Awesome. So now we have text displaying on the game in all its glory. Now, there's some things that we definitely want to improve about that. Like, you can see right here, the space between the W and the O is very, very small. They're actually kind of overlapping. So that's because we want to actually go ahead and start using the dimensions of the characters when we're printing them. This probably also isn't the nicest way to go ahead and print words because it requires like 4 function calls, right? Maybe we want to go ahead and do that in a nicer way. It also doesn't prevent us or, point out that we are making a mistake. We do something like this, right? That's a really weird looking wolf. If I do something like this, we're going to get a similar problem where, that looks just awful, right? Like, what do you even do with that? So we want to go ahead and handle cases like that. But yeah, I think we are in a really, really, really cool and good position. And go ahead and illustrate that we can still move around our guy. I'll go ahead and put this like that. Another thing that is a little weird is, drew those at the same space. You notice that we are, this is positioned at 0, 0, right? But we don't necessarily want the W, the very tip of the W, to start at 0, 0. That's what those X offset and Y offset values are about. And if I go ahead and look in the scratch buffer right here, we can get a really good illustration of that. So you see, I draw the A. This is the size of the grid where I'm drawing. But you see that the A is starting not at the very tip, right? So if I do something like this, we see the character is kind of centered in, right? And if I draw like an exclamation, it's centered in. So actually, that's really clear right here if I try to draw a wolf exclamation mark. We can see that we positioned that 50 units away, but, it's kind of like still hanging right on that W. So that isn't great. And in the next video, we can go ahead and change that.